We're going to do two things. One thing we're going to do is learn how to determine if two matrices are inverse matrices. And we are also going to learn how to find the inverse of a 2 by 2 matrix. So today I'm only dealing specifically with 2 by 2 matrices. So before we get started, let's go ahead and go over some vocabulary. All right, so the first vocabulary word is going to be identity matrix. All right, so an identity matrix is going to be the multiplicative identity of an n by n square. All right, it is denoted by I. All right, so basically, it is going to be two things that multiply that give you one. All right, only thing is with a matrix is not a single number. All right, it is an array of numbers. So it's a little bit different because it's not one single number. So the identity matrix, which is equivalent to the single number 1 in number terms, the identity matrix is going to be an arrangement of 0 and 1s, where 1 is going to be the leading coefficient on each row. Okay, when each row same row, same column element. So for the very first element, this would be element A11. All right, so A11, row 1, column 1 is going to be a 1. All right, everything else outside of that element is going to be zeros. All right, so then if you would go to the second row, all right, the column and row that would match would be A22. Okay, so that is the row and column where the number would match, and so that one would be a 1. Everything else outside of that would be zeros. If I wanted to add another row and column, all right, would be a 3 by 3. So the one on that particular row would be an element A33. So it would be like right here. So you would continue that pattern with the ones going diagonally. All right, those would be your identity matrices for those following n by n matrix. All right, so the identity matrix is basically like the number 1, but it's the number 1 for a matrix. So an inverse matrix. All right, an inverse matrix is going to be the matrix where if I multiply it by another matrix, I get the identity matrix. So two matrices are inverses of each other if you can multiply them and you get the identity matrix back. All right, so it's in number terms, it's like multiplying two numbers to get one. All right, whereas now I'm going to multiply two matrices to get the identity matrix. Okay, so you denotate an inverse matrix by the capital letter of that matrix name and with the exponent of -1. So you've seen this before when we've done trig, sine, cosine, and tangent. So remember when we talked about the sine inverse, it was sine to the -1. Cosine inverse was cosine to the -1. And tangent inverse is tangent to the -1. So anytime you see an exponent of -1, it means the inverse. All right, so we have two more vocabulary words, invertible and singular. So a matrix is said to be invertible if it does have an inverse. If the matrix does not have an inverse, then the matrix is singular. Okay, so like we just said previously, inverse matrix, where you multiply two matrices to get the identity matrix. Well, that is how you're going to determine if two matrices are congruent. I'm sorry, not congruent. That's how you determine if two matrices are inverses of each other. So I would take the matrix, the two matrices that I have, and I will multiply them by each other to see if I get the identity matrix. All right, so let's take a look at example 1. Example 1 says determine if matrix A being -3, 2, -1, -2, 1, and matrix B, which is 1, -2, 2, -3, are inverse matrices. All right, so if they are inverse matrices, that means A has to be an inverse of B, and B has to be an inverse of A. So what I want to do is I want to check if I multiply the matrices AB, do I get the identity matrix? All right, so that's what I'm going to do. So I'm going to have matrix A times matrix B, which would give me -3, 2, negative 2, 1, times 1, negative 2, 2, negative 3. All right, so let's revert back to multiplying matrices. So remember, you multiply rows by columns, and you have to multiply the corresponding row and column elements. So if I am multiplying the first element on the first row, then I need to multiply the first element on the first column on the other matrix, because remember, it is rows by columns. So that means I'm going to get negative 3 times 1 plus 2 times 2. All right, then I will move to the next row and column. So now I'm going to do negative 3 times negative 2 plus 2 times negative 3. All right, those will be my first two elements. All right, then I'm going to move to the second row and do the second row by the first column. So that would be negative 2 times 1 plus 1 times 2. All right, and then the last row by the last column. So that would be negative 2 times negative 2 plus 1 times negative 3. Then I can simplify. So negative 3 times 1 is negative 3. 2 times 2 is 4. Negative 3 plus 4 is positive 1. All right, then I move to the next one. Negative 3 times negative 2 is negative 6. 2 times negative 3, I'm sorry, that's positive 6. So negative 3 times negative 2 is positive 6. And then 2 times negative 3 is negative 6. Positive 6 and negative 6 is 0. Negative 2 times 1 is negative 2. 1 times 2 is positive 2. Negative 2 and positive 2 is 0. All right, so then for the last element, I get negative 2 times negative 2, which is positive 4. 1 times negative 3, which is negative 3. 4 and negative 3 is 1. All right, so I get the identity matrix. All right, so therefore, I do know that B is an inverse of A. Now I have to figure out, is A an inverse of B? So now I would reverse the order. All right, and I'm just going to do this down here, example 1. So now I'm going to reverse the order. So now I'm going to do B times A. Because remember, it has to work for both of them. So A times B and B times A have to both equal the identity matrix. If not, they're not inverses of each other. All right, so one can be the inverse. So A can be the inverse of B and B not be the inverse of A. But if they are not the inverse of each other, then they are not inverse matrices. All right, so now I'm going to do B times A. So I'm going to put B in the front this time. So now I'm going to have 1, negative 2, 2, negative 3, times negative 3, 2, negative 2, 1. So again, it is going to be rows by columns. So 1 times negative 3, which is negative 3. And then negative 2 times negative 2, which is positive 4. All right, so then I'll do first row by the second column. 1 times 2 is 2, plus negative 2 times 1, which is negative 2. Then I do 2 times negative 3, which is negative 6. Negative 3 times negative 2 is a positive 6. And then 2 times 2, which is 4. And plus negative 3 times 1, which is negative 3. All right, and then I am going to simplify one more time. Negative 3 plus 4 is 1. 2 plus negative 2 is 0. Negative 6 and 6 is 0. And then 4 and negative 3 is 1. All right, so they are both they are both the identity matrix. So the answer would be yes. They are inverse matrices. All right, so now for example 2. Right, and what I want to do before I get into example 2, I want to change one of the numbers. And I'm doing that for a specific reason. All right, so let's just change this to a 2. All right, so that didn't come out how I wanted it to. So I'm going to try that again. So this first 3 here, I'm going to change that to a 2. Okay, so let's do A times B. All right, so A times B is going to give me -4, 2, 3, -2 times 2, 3, 3, 4. All right, so I want to multiply these. So -4 times 2 gives me -8 plus 2 times 3, which is 6. All right, then I'm going to move to the next column. So -4 times 3, which is -12, plus 2 times 4, which is 8. 3 times 2, which is 6. Excuse me. Plus -2 times 3, which is -6. And then I'm going to do 3 times 3, which is 9, plus -2 times 4, which is -8. All right, now simplify. -8 plus 6 is -2. -12 plus 8 is going to be -4. 6 plus -6 is 0. 9 plus -8 is 1. All right, so notice this here, we did not get the identity matrix. All right, so because we did not get the identity matrix, the answer would be no. All right, so again, when you multiply them first, A times B, right, you have to get the identity matrix. Also, if I reverse it and do B times A, I also have to get the identity matrix. If I get anything outside of the identity matrix, 1, 0, 0, 1, then the answer is no. They are not inverses of each other. Okay, so let's move to the next topic. How do I find the inverse of a given matrix? All right, so there is a formula. All right, that formula is in the middle. All right, so A to the -1, and remember that -1 means inverse, is going to equal 1 over A times D minus B times C times the matrix D, -B, -C, -A. I'm sorry, not -A, regular A. All right, so this right here represents the determinant. All right, so remember, determinant of a 2 by 2 matrix is where you cross multiply, all right, and you find the difference between those products. That is the determinant. So you would do 1 over the determinant, and then you will multiply this rearranged matrix. So let's look at example 1. All right, so remember the elements of the matrix would be as follows: A, B, C, D. All right, they just would go in alphabetical order, starting at the first element and going in your rows, left to right. All right, so the first thing I'm going to do is find the determinant. Okay, the note that you need to make, I'm going to write it down here at the bottom. I'm going to start. If the determinant is 0, the matrix does not have an inverse. All right, and if it does not have an inverse, that means it is singular. All right, so let's talk about why. Why is this the case? And I'm going to make this a little bit smaller. All right, so let's talk about why. Think about it. If the determinant is 0, I would get a fraction of 1 over 0. Well, I can't divide by 0. That's undefined. And if I can't divide by 0, if this is undefined, then there's nothing for me to multiply this matrix by. Okay? So if the determinant is 0, that saves you a lot of work because there's nothing else to do to the problem because it's singular. All right, so the first thing you always want to do is start out by finding the determinant first to see if you even need to finish the problem. All right, so again, the determinant, you find the determinant, and that would be DET of A would equal A times D minus B times C. All right, so I would do here 8 times 2 minus -3 times -5. This would give me 16 minus -15. I'm sorry, this will be a positive 15. Because the negative times the negative is a positive. So this will be 16 minus 15, all right, which is 1. So that means the determinant is 1. It's not 0. So that this matrix does have an inverse. All right, so now I can do this into my formula. All right, so my formula is going to be 1 over the determinant, which we just found to be 1, times this rearranged matrix. So D is going to be the very first element. So I'm going to look at my given matrix. D is going to be 2. So I'm going to rewrite 2 as the very first entry. All right, the next entry is going to be the opposite of B. So I'm going to find B. B is -5. I take the opposite of -5 is +5. So this term is now going to be +5. All right, then I look at the next term, which is -C. So it's opposite of C. Well, C here is -3. So the opposite of -3 is +3. All right, and then the last element would be A. And in this matrix, A is 8. All right, so 1 divided by 1 is just 1. All right, so then my scalar is 1. And to multiply by a scalar, you do distributive property. So that means I will multiply 1 by everything inside of this matrix. So 1 times 2, 1 times 5, 1 times 3, and 1 times 8, which would give me back the same matrix because 1 times anything is itself. All right, so this would be your inverse matrix. So the first example. All right, so let's look at example 2. All right, so again, first thing I want to do is find the determinant. So that will be 6 times 6 minus 4 times 9. 6 times 6 is 36 minus 4 times 9, which is 36. The determinant is 0. All right, so because the determinant is 0, I can't divide by 0. This is singular. Oh, I misspelled it. Sorry. All right, so give you some time to try example 3 and example 4. All right, so remember, look for the determinant first, all right, by cross multiplying and then finding the difference. Once you find the determinant, all right, you want to rearrange your matrix. So you want to take your A, B, C, and D and rearrange them in this order. D, opposite of B, opposite of C, and A. And then you multiply whatever your fraction or decimal or whole number is by each of the new terms. So go ahead and press pause to give yourself an opportunity to try both of these examples to see if you got it right. Okay, so example 3, your determinant should have been, you would have gotten 8 minus -12. All right, so your determinant would have been 20. All right, then I would have done 1 over 20 times the matrix 4, positive 3, negative 4, and 2. All right, so that would have given me 4 over 20, 3 over 20, negative 4 over 20, and then 2 over 20. All right, and of course, you always want to reduce your fractions. So if I would have reduced this in fraction form, I would have gotten 1 over 5. All right, 3 over 20 will stay the same. Negative 1 over 5. And 1 over 10. All right, you also could have put your answer in decimal form. So 1 divided by 5 is 0.2. 3 divided by 20 is 0.35. Is that? It's 0.3. 0.15. I did that wrong. 0.15. Sorry. All right, so 0.15. All right, and then this would be 0.2 and then 0.1. All right, so either answer is acceptable. You could have done it in fraction form or decimal form. All right, and then the last problem. All right, you would have gotten the determinant, so you would have done negative 12 minus negative 12. All right, so that would become negative 12 plus 12, which is 0. So that matrix would have been singular. All right. Hopefully this video helped you to understand more how to determine if two matrices are inverse of each other, and also how to find an inverse of a 2 by 2 matrix. Thank you so much for watching my video.